Hello everyone, this is a video lecture for pre-calculus. We're going to do 4.5, which are applications. So basically word problems. There's two formulas that we're going to be working with. Well, one, essentially, is this guy. It's basically the same as the PERT formula. There you go. And so K is your rate, A naught is your principal, P, initial, that kind of thing. Yeah, and everything else is the same. So that's A naught. Let me actually write that up. A naught. And how I remember how it is spelled is it's kind of similar to this. Oh, if I can get this to work. There we go. Yay! I know, I amuse myself. Okay, so A naught. Now, I got 4, 5, 1. A is equal to 938.8 e to the 0.007t. It's talking about population. T is years after 2003. And they say, what is going on? What's the population in 2003? So this many people. Okay, well, this is almost a little easy here. We have a formula, and they say T is years after 2003. What's the population 2003? What's your T equal to? You're going from 2003 into 2003. How many years have elapsed? 0. So you just plug that in and you're done. So you don't have to even plug this in. I'm going to show you what happens like once, and then you'll never have to see this again. So that's not a T anymore, that's a 0. Well, anything to the 0 power goes away as a 1. So 1 times the 938 is 938.8. And that's your answer right there. That's it. Very simple. Okay, 4, 5, 9. It says that the population in 2007 was, I'm just going to put a little arrow to kind of say it was 53.7. The population is projected to be in 2024 to be, they don't know. I have a rate of 0.0084, and that's it. That's all they give you. So they say figure out how much it should be in 2014. Well, this is our initial amount, and so this is my A naught. This is going to be my final answer, A. This is my rate, so that's my K. How much time has elapsed? Look, right there. How much time has elapsed? 17? Right, 17. And so let's put it all together. So A is equal to the 53.7 e to the 0.0084 times 17. So to find it out, you just, I don't know, plug it all in, get an answer. Definitely using Desmo Scientific. We're using a scientific calculator for all of this. And there we go. I don't know, people, population, million, something like that. Whatever they say. Okay, another similar problem to this one. Similar. I have the population in 2006 to be 31.3. And then they say, okay, well, the population's projected to be, in 2024, it's projected to be 42.8. I think these are all in millions, by the way. So they say, what's my rate? What's my rate? Okay. Well, let's put it all together here. So this is my A. This is my final amount. This is my initial amount, A naught. And how much time did it take to get there? It looks like it's 18 in this particular case. So I got 42.8 is equal to 31.3 e to the k that I don't know times t is 18. Solve for k. All right, awesome. So let's solve for k. There's a steady style, a pattern, I would say, to getting these done. I'm going to show you the long way right now, and then I'll show you the quick way when I'm done. But you have to see the long way to kind of understand the quick way. So first off, I'm going to divide. I'm going to write this on the side here. Divide, okay? So I divide by the 31.3 onto this side. And normally I would go right to the calculator and find out what that is, but not today, not this time, okay? Because I want to leave it alone so you can see what's going on. Okay, so now I want to get rid of the e, and so I ln both sides. So what did I do here? ln. And of course, e and ln will cancel. So I got ln of this big fraction. Again, I don't know what that fraction is. I don't know what the decimal equivalent is. It's fine. Just leave it alone. It's ln, locked in. It's not going to change at all, so just leave it alone. And then we need to solve for k still. So what's the next step is I'm going to divide by 18. Divide. There's this particular pattern. So k is equal to ln of the 42.8 divided by 31.3, and then all over 18. Okay. So what did we do to get to this point? Divide, ln, divide. That's the quick version here. I'm going to give you the answer, of course. I go and type this all into Decimal Scientific, and we get this answer here. That's my rate. And that's it. You're done. We're done with the problem. Now, if we ever are encountering this situation again, let me use a green color. If we're ever encountering this situation again, we can quickly get to the answer. So we have to start with some kind of, I guess, style like this, where we're either solving for k or for t, something up here in the power. And then what I do is I see this as a pattern. Okay, notice that I have the 42, the 31, and then the 18. So in my progression, in my pattern here, I got 42, 31, 18. Well, if I go to the answer here, you can see that same pattern here, 42, 31, 18. It's the same three numbers, and it's in a certain way. So if you set it up like this, the answer looks just like this every single time. So if you wanted to do kind of like a formula to what this will look like, then you could see to solve for x, I'm going to say it's ln of a over b, and then all of that divided by c. It's a formula, a form, a pattern, I guess you could say. You could do the divide, ln, divide the long way every time, but this is really fast. Please do this. It really makes it so much faster, and I'm going to do it too because I don't want to sit there rewriting all that so much. I mean, look, that's a whole page, all because of one little thing where I could just skip to the end and I'm done. So I'm gonna try to make it a little easier. Of course, not every problem needs that, but when you see it, do it. Okay. Moving on. The next question is talking about carbon 14. Now, immediately when I see and hear that, I know that there's a formula for it. A is equal to A naught, E to the negative 0.000121 t. Now, if they supply it, that's awesome. And then you have it there with the problem, that's great. If they don't supply it, and they say, oh, well, the half-life of carbon-14 is 5,000 blah, blah years or whatever, I don't even know how to do that. I mean, okay, I do. But my point is, it's like unnecessary. When you see carbon-14, this is the formula. So if you want to like write this down on your note card for exams and stuff, that's an awesome idea, because if the problem doesn't have this formula, now you would. Now, here we go. It says carbon-14, blah, 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 and we have 31% of the original left over. Okay, so they're assuming that my original amount, when they say that, they're assuming a 100%, okay? So they assume a 100%, and they say, now we got a 31, what should we get? So let's plug it all into the formula. My new answer is the 31%, while my original is 1. Like 100% is a 1.0 kind of thing. 0.000121t. Now, the 1.0 you don't really need because 1 times anything is itself, it's no problem. So how do I get rid of that? E is I ln both sides. Now, I know that we're basically just doing the E, the divide, ln divide all over again, and I totally get that, and you totally could do my previous formula. But it didn't have the exact same format. And so although perfectly legitimate and you can do it for your own, I just didn't choose to do it this time because I felt like the 1.0, just get rid of it, and then it didn't look the same, and it's up to you. You can do whatever you like. Divide by the 000121 on both sides. And so then I got my time is equal to ln of the 0.31 all over this negative 0.000121. Go to the calculator, and I got 967.9.198. Okay. Cool. Next question. 4.5.21. So this one's talking about half-life. And if they ever give you a half-life problem, there's a certain set of formulas that you'll probably want. Now, they don't give these formulas to you. These are chat exclusive, okay? You got the chat exclusive formulas here. So my K, my rate, is ln of 0.5 divided by the half-life that they give you, which is going to be like a whole number or maybe a small decimal or something. And so this is my rate. And then T, my time, is ln of some kind of a percentage that they give you divided by the K, the rate that you just found. So this is going to be my time. So it depends on what they're asking for, but these two formulas here are definitely note card worthy, and I use them all the time throughout Half-Life section stuff and whatever they ask. I use them all the time. And so in this particular case, they say K is my rate is equal to negative 0.041, and they say, what is the half-life? Now, this is actually a new problem to us. Again, our 1414 class didn't do this, I don't think, but we can use this formula to definitely get what we want. So I'm saying then the 0.041 is equal to ln of 0.5 divided by the half-life, which I'm just going to do HL. So I need to solve for half-life. I'm going to multiply half-life to the other side and divide by this decimal to the other side. So half-life, that just does not look good. Hold on. Half-life is equal to ln of the 0.5 divided by the negative 0.041. Calculator, and I got 16.906 years. There you go. Cool. Okay, so I didn't use both of the formulas here. I know that it'll come up eventually. I also didn't use them conventionally. Normally I just like say, oh, you just plug it in, you get an answer. But hey, you do what you can. You got it all now, so moving on. 4.5.29. I have A is equal to A not e to the kt. I think they give you that formula here, which we've already seen it, but they give it to you, okay? And they say that half-life is equal to 15 years. Okay. And they say how long to decay to 60% of the original. This is a classic. I'm going to use these two formulas, okay? So step one is that we need to find the rate. And it's very simple to find the rate. We got ln of 0.5 divided by the half-life, which they gave it to me was 15. Put it in the calculator. And again, I'm just using my notes because I already did all of my calculator stuff earlier. Negative 0.046298. And I put a little note here. 6 is safe. 6 is safe. It's kind of like my little saying here because you go out 6 decimal places, you'll definitely be safe for whatever my math lab's going to throw at you. So 6 is safe. Now, I went more than 6, but hey, it's okay. 6 is safe. Go out about 6 or more, and you should be good to go, okay? Especially on this particular calculation. Now, T is my time, and let's see what we got there. They say how long to decay to 60%. And so if you go back to the formula, that 60% goes right here. That's my percentage. Remember that it's in decimal form. Divided by the rate, which we just found. So again, I'm not writing those two formulas down all over again, but right here, these formulas are right here. All I'm doing is literally copying those in. That's always a 0.5. Why do you think that's a 0.5? Well, it's representing 50%, which, oh my gosh, it's half. Wow, really? So that's why we're doing all this. Exactly, just copy paste whatever we had. Um, there we go. So, so I put this into the calculator. And I got 11.0544, blah, 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 blah. Actually, not so blah, blah, blah. Okay, hold up. So, yeah, 5.054. Yeah, that's awesome. This is one of the answers, and the other answer that you have got to click and make sure you select is years. It's kind of like part A, part B, kind of, but they're all kind of mushed together. This is 50% of the credit on this problem. So if you don't click years, you get half of it wrong without even doing any math. So, but you can also get half right without doing any math. 4.5.37. This is a logistic growth model. Logistic growth and all that stuff. We had seen this earlier in an earlier section, but this is the section where it really has a lot more applications. So I have f of t is equal to the 112,000 divided by 1 plus 4600 e to the negative t. Okay. Now, it says here in my notes that I already did this problem. I don't really know when, but yeah, this is an easy problem to do. You're just going to plug stuff in. So part A, it says something about the initial population of something or other. I'm not going to give you the details because I don't like going in and all that stuff. So, but you're just going to plug in 0, plug it in, bloop, plug it in and get a number, okay? Part B says, hey, what's going on in week 4? So, hey, guess what's going to happen? T equals 4. You're going to plug it in. Bloop. And then C, it says, what's the limiting size? It's always the numerator. It's always the numerator. Always. So you type that in, you're done. Okay, so there's your numerator. Ta-da! I'm pretty sure I did this back in 4.1. So, moving on. That is totally not necessary. I just maybe wanted to like show you like, hey, we got that problem again. Okay, this is another logistic growth model, but it's actually really neat and it's different. So I think we get to solve for x or something, and no, we actually don't. We just compare something. Where's... Okay, the next one after this is a solve for x. Okay, I knew that we would solve for x eventually. I just didn't know where it was. Okay, so I'm retyping what we have. I do believe that this one was back in Algebra 1414, same kind of problem. They say that x is years after 1949 of all years, and we're supposed to compare our result with the 2007 data entry that they have. So if you're looking here, my x is going to be years after. You subtract them, of course. And I got 58. So in my math lab, before we get too much further, they have an x and a y table, blah, 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 and then they have a 58, and then they got blah, 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 and then they have a 6.4, okay? What we're doing is we're going to get a result from here, and we're going to compare it with the 6.4, and either they're more or less or the same. So let's plug this in. So I'm going to go back to the original and plug it in, which really you just put this all into the scientific calculator and you get an answer, and that's it. So put the 58 in there. And when I do it, I get a 6.536. Okay, so this is cool. But they're not quite... I'm not going to box it in because they don't really want that answer. They want over, under, same kind of thing. When we compare them, this number is overestimating. Not by much, but it is overestimating. And that's going to be your answer. Just click overestimate. Okay, well, that was kind of lame. 4, 541. So this is the last question in this chapter, actually. We're basically done here. Now, this is a really cool problem, honestly. This one here is talking about world population. And so they're wondering what is the world population at this amount of time, how much time until we get to this amount, et cetera, et cetera. It's really neat. So they say that X is years after 1981. And they say, when is the population equal to 9 billion? Now, at the making of this video, we have not reached 9 billion. I'm pretty sure we have not. So, but this, anyways, we have this problem here. It says basically solve for x, solve for the time, given what we have here. Now, 9 is going to go right here. The reason why I find this is a really cool problem is because I know the other logistic growth problems and how they function. So we could see what the initial amount was, its growth rates. You can see right here, the top is the limiting size again, right? I mean, this is off topic a little bit, but limiting size. They're saying in this problem that the limit to, I guess, Earth's population is about 12.57 billion. So it'll max out there over time. Like, we only have so much dirt to go around. But that's pretty cool. I don't know. It's just neat to kind of see these kind of models and stuff. So when are we going to reach 9 billion? So what we're going to do is solve for x. Now, this is a long journey. This is a lot. Like, on my notes, I got a big page full, so definitely get some room here. I'm going to first start off by multiplying this to the other side, okay? Basically, we have way too much denominator, and I need to get rid of that fraction because it is just over complicated. So that's step 1. Step 2 is I'm going to divide by 9 on both sides. Now, I'm going to, as I go down here, I'm going to tell you what I do with my scientific calculator is I have a running total, a running tally. And so in a way here, whenever I do some kind of math, I actually go and get the value. This is 1.39666, kind of something like that. Okay, so we have this value here in my calculator. And now the next one I'm going to do is say like answer something or other, -1 or divide by something, all that kind of things. So I'm going to -1 on both sides, okay? In my scientific calculator, in Desmo Scientific, I am having to do this -1, although I know the answer is going to be pretty basic, you know. That way you can have that value sitting in the calculator. If you're confused about what I'm trying to say here, is that I have 1.39666 sitting in the calculator, and I say -1. And what it happens is when you put -1, it says answer -1, and then it gives that next value, which would be the 39666. So then I'm going to say, okay, well, now I want to divide by the 4.11. Divide by 4.11. When you say divide, it's going to say, oh, you mean the answer divided by 4.11? Yes. And then you get your new decimal. You hit enter and you get a new decimal. So what it's doing is it's like storing that number as you go. And again, 6 is safe. I know I just did about 5, but 6 is safe for what we're doing here. Divide here, and I get a 0.0965125.7. So I was overzealous on that one there. How do you get rid of the E? You ln both sides, right? And they cancel. So E and ln cancel. On your scientific calculator, in Desmo Scientific, you're saying ln of your answer. And you already have your answer in for the previous problem, so you say ln of your answer, and it gives you the new number. So negative 2.338082. Okay. Divide by the negative 0.026 on both sides. 2 negatives are going to make a positive. Again, you're just doing that all in the calculator. So x is equal to, you put this all in. Final answer, here we go. I got 89.92623 years. Whew, we did it. That was a long journey there. I'm sorry. No, why is it wrong? Because it's 1981 plus the 89.926 whatever, and it actually turns out to be 2071 whenever you round it. So 2071 is your answer, like AD. That's kind of what they're going with. Cool, we did it. Now we did it. Oof. And we're done with chapter 4. So that's all I got. Thank you very much. Have a great day.